So I hope you all can hear me. I'm starting a new thing, which is ray tracing, which is XR 0.1 of it. Right. So we'll be doing all of these. We'll be starting off with this. Let's just run the setup. I think I want to save it to my GitHub or something. Right. Save as copy in GitHub. Yeah, it looks right to me. Create using Colab. Then we gotta go to the GitHub after it's saved. Then we gotta go to the GitHub and then open it in Colab, and now we'll be able to do it better, right? Let's start by running it. Run anyways. After we connect to the compute backend, the line will come here which says saving to GitHub. Okay, while this runs, let's see what goes on. Stand this. Right, rays and segments. Our camera will be a single point in the origin. The camera will emit one or more rays, where rays are represented by an origin point and a direction point. Conceptually, the ray is emitted from the origin and continues in the given direction until it intersects an object. We have no concept of lighting or color yet. So we'll see a pixel on our screen should show a bright color, so the ray of origin through it intersects an object, otherwise the screen should be dark. Okay. Let us implement the x, y, z dimension. Okay, let it be 0. Okay, got it. It's working? Oh, that's interesting. Despite the thing going on. Okay, I'm now gonna read it, just run it. Okay, very good. Okay, so now you can see this, right? It's a basic idea. Implement the following make rays 1D function. So it generates some rays coming out of the origin, which we will take to be 0, 0, 0. So a ray is basically has an origin point and a direction point, basically like a vector line, right? You have an origin and a and some direction vector which you multiply by lambda or something. Conceptually, the rays emitted from the origin. Wait, we haven't exactly fixed this. Let me just take a look. Do window capture. Yeah. So, anyways, you guys can see this, but what I want to do right now is I want to go to YouTube to my studio and share this link with all my friends so they can see this content live. Copy. Let's get. I know you guys can't see anything, but I'm gonna share it anyways. Okay. Oops. The thumbnail is I know is this, but maybe you gotta do something else like Raytracing, pytorch. Ooh, this is a really cute one. Not mine though. Okay, it's okay. Let be inops. We won't change the thing. Let's ensure this works out. Okay, so now let's get to it. This is it. Okay, implement the following make rays 1D. Num pixels, the number of pixels in the y dimension. Since there's the number of rays. Let's read this again. Objects are triangles. The triangles are represented 3 points in 3D spaces as 9 floating points per triangle, correct? Pikachu, okay. Origin point and direction point. Conceptually, the ray is emitted from the origin and continues in a given direction until it intersects an object. So the ray is emitted from the origin and continues in a given direction until it intersects an object, correct? So I understood just now as an origin vector plus lambda times a direction vector. We have no concept of lighting or color yet. So for now, we'll say a pixel on a screen should show a bright color if a ray from the origin through it intersects an object. Otherwise, our screen should be dark. Okay. Implement make rays 1D. I don't actually get it. So we have to do 9 pixels. I see that, right? And then since 1 ray per pixel is number of rays, correct. At x equals 1, the rays should extend from y limit plus y limit to minus y limit. Huh? Okay. I see. I see. So, what they want here is that they want you to take something from plus. So 1 divided by 9 will be, I don't know. I don't quite get this. So they do this from 9. Yeah, we have 9 of those. So we'll have minus 1, minus 0.5, minus 5. So you'll have exactly minus 1, minus 0.75, minus 0.5, minus 0.25, 0. Oh, okay, I see. You have exactly 9 in between these. Correct. So number of pixels in the y dimensions, and there's 1 ray per pixel, is also number of rays. I know what to do. I can do it, in fact, right? So this one should just do I mean, I know how to do it in a for loop. Let me just see how to do it in a for loop. A for loop, I would do something like for, so the y limit, up limit equals y limit. Sorry. So then, how do I tell the computer how to do this? Well, you have to do it from 1 to minus 1. That's 2, and I don't know. We're gonna divide 2 correctly into 9 bits, right? So let's look at that. If I want to divide the numbers between minus 1 and 1 into 9 equal parts, how to do it? And I know what the answer. I'm just seeing what the logic is, right? I see what my mistake was. So we need to divide it into 8 equal parts. And so, yes, so you need to do it into 8 equal parts, from plus limit to minus limit, right? So if we got to do it in n minus 1 equal parts. Parts equals minus 1. What's the next thing? We got to divide plus y limit to minus y limit. So our step would be what? Step equals y limit times 2. Sorry. Y limit times 2 divided by parts. Right. For I'm not supposed to use a for loop. I know, because it's pytorch. But for I suppose this is what we checked then, which is first function. I shouldn't see the answer. Maybe the answer is there. Okay. So for I in range, but we know that, right? We know what we're supposed to do. We know for I in range. So what pytorch functions can we use to do it? Gosh, I don't know the pytorch API well enough. What? 1 comma is 9 comma 10, right? Same thing. Okay. So we start off at that, right? Step times I think this is it, comma 0. Just delete this and then make this 9 comma 1.0 for a moment. Okay, so I gotta do this in pytorch instead, right? Let's do this for 10. One minus 10, 0, right? Yeah, just the difference is that's a tensor and it's not. So now we have this. How do you pytorch now? This is actually quite simple. There's probably some pytorch range function. This is best. This space is good to ask GPT all these things. Import torch, import st. Okay. Huh? Okay, let's do this. Let's understand this. Okay, parts equals num pixels minus 1. Okay, step equals the same thing as our thing. Indices equals torch dot a range parts plus 1. Okay, so what does that mean? I do I see that this is the for part of our loop, right? This is the for part. Apologies if you hear the background noise of someone drilling upstairs. It's not the best. Indices equals this, right? I see. So what they're doing is they're creating this part first. They're creating this part first. What they're doing is that they're doing indices equals t dot a range parts plus 1. Correct? Yeah. Y vals equals indices minus y limit. Oh, okay. Indices times step plus minus y limit. I see. That's our right hand side over here. No. That is not a right hand. That is just this value. There's just minus 10, minus 7.5, etc., etc. So we gotta do, yeah, I get that. Oh, so we gotta toss that stack. Directions equals torch dot stack p dot zeros parts plus 1. Tiered 1's part plus 1, comma y vals, comma t dot zeros parts plus 1, right? And then our initials equals t dot tensor 0, 0, 0 times parts plus 1 to return t dot stack initials, comma directions. No, there's a mistake over here. Okay. What's the issue? Takes from 1 to 2 position arguments. Oh, I see. Wow, okay. I see. This is why I love ChatGPT. It just makes learning so much easier. No. What's going on? Okay. But just do that then. Wait, let's see what's going on here. We have this, right? What's the direction dot shape? This is tiered inch parts plus 1, which is what? It's a vector of range num pixels, in this case 9. Num pixels 9, right? Y vals equals indices. This is also that. This is also of range, not of length 9, right? Print y vals dot shape. Torch size 9. I got it. T dot stack parts plus 1, right? Ones. Print directions dot shape. It's 9 by 3, right? Got it. and then initials, I hate the initials dot shape. That's the issue. So it does give. My English is worse than. Ah, I see. That's smarter, definitely. Huh? What's going on with this? Oh, we haven't returned anything, that's why. Let's. Ooh, super cool! We did it! And let's just ensure. Assert raise 1D equals first func 910. Works. Works. Okay, which means you're getting the right answer. Very good. Right? Next. Suppose your line segment defined by points L1 and L2, then for a given ray we can test the ray intersects the line segment like so. Okay. Ray up intersection. So your line segment L1 L2. Now the equation saying the camera ray is O equals UD, an object line is this. So okay, and we can just check if there exists some U such that we intersect any points in this, I guess. In 3D or in 4D, There's no necessity that points in that non-parallel lines intersect. And GPT 3.5 is completely outdated. Oops, I zoomed too hard. Okay, let's start this. You can do this by inspection, which for each of the line segments so I see the idea, which is that okay, what's going on here? No, I get this part. So we're saying that this is it, and this is like standard high school vectors, where you just, you know, are doing some sort of yeah, I get that. Okay, C equals this is my V, I guess, right? This is my L1. T dot manual seed. What is manual seed in pytorch? Okay. So this sets the seed for random number generator. Okay. What is? Yeah, I agree. Okay, anyways, P equals lambda L1. What is L1 now? Plus V times this. X comma Y equals. Where did we set up L1 again? Did we decide L1 comes somewhere here? Oh, it's here. L1 L2 equals T dot ran 2 by 2. I see. So X comma Y equals zip P minus 2 and P2. Okay, got it? What we're doing right now is just taking two random points and drawing it out, right? So now I see what's going on here, but I'm not sure how it connects to this drawing and line intersecting thing. Oh, this is very fun to play around with. I love 3D visualizations. What's going on here? Okay, O plus UD equals this. UD minus V. You put all the vectors on one side and all of the Okay, I see that. I see that too. It'll be dxu plus lxv plus dyu. This is correct. Looks right to me. Okay, that's fine. So you have to just use the inverse, find the inverse of this, right? And then check. So what you gotta do is you gotta say that, hey, this is my they, a tensor. Okay, so so we just gotta solve this. I don't get the difficulty, to be very honest. It's gonna take number of points equals 2 and number of dimensions equals 3. It's gonna be a 2 by 3, so that's O and D, correct. Segment is again a 2 by 3. Okay, and we gotta handle this thing where they're parallel. I mean, why should it return it should throw an exception, I see. What exceptions does torch.linear algebra.solve do? Let's see what. Yeah. Not a good day for my nose. Try. Okay. We need to do that. We really need that. So we can just do something like how do we set this up? What's our left side of here? What's our AXB? Okay, so A is dx dy, right? What's our D over here? D is they colon 1, I guess, right? They colon 1. I think so, right? So then we gotta concatenate. We gotta. I don't understand. So our O, our L1 minus L2 is segment colon 1 minus segment colon 0. This are gonna fail. That goes without saying. The question is, do these give us an error? What's the term 2? Just to mess with things. Good. So yeah, this is what we're getting, right? Yeah, 2 by 3 tensor. So you're gonna ask ChatGPT if I have a 2 by 3 tensor in torch, how do I get the second part? And Python lists, I would do list colon 1. Oh, it's the same. Okay, very nice. That's very good. Okay, now we gotta do this thing. We gotta concatenate. Oh, okay. L1 minus O and L1 minus O. Okay. L1O equals segment 0 minus, I don't know what happened here, but minus they 0. So A equals what? A equals, we're going to concatenate the D and the L1. So stack or concatenate? If I have this is a 2 by 1 tensor. I have one more 2 by 1 tensor. Stack means they'll go one above the other, right? Let's just check that. Cat makes sense. T dot torch dot concat. We need D and we need L1, L2. It is closed. What do you mean? Oh, B equals, it's just a single one, right? It's just our 0. T dot lineage dot solve A comma B, and what does left equals true mean? Oh, okay, that is okay. The input tensor A must have at least 2 dimensions, but it does have 2 dimensions. Huh? Oh. Correct. The Z is ignored here, right? So we can just ignore the Z. It's 2. Dot unsqueeze 1. 2, 1, correct. Same thing with this, right? Ooh, no, but we're failing somewhere. Because we're not checking for the U and V. That's okay. Let's remove the prints now. Yeah. Gotta check now if u is greater than 0. Return u greater than or equal to 0 and zero less than equal to v greater than equal to 0 and v less than equal to 1. Okay, let's there is, comma they print segment is let's do the first example. This is working right. So D should be, well, what? They, right? D should be 1 minus 10. Correct. It's working out fine. They is this. Sorry, oops. Correct. Okay, this is my they is my segment. My D is this, right? My don't need this anymore. Let's look at this one right here. They is this, segment is this. So, which means that our they is just the O and D, right? So then we gotta have our D as the first 2 points of our A, right? I don't want D as this. It's okay. Right, our first 2 points of the A are the first points of D, 1, comma 7.5, correct. And then the L1 minus L2 is 1 minus 1, which is 0, minus 6 minus 12, which is 6, correct. B is L1 minus O. L1 is 1. O is this 1 and minus 12. Looks right to me. I don't see what the issue is. We're doing it correctly. Maybe we gotta print our U and V also. Here it is. I should have deleted this. Sorry. Here's the thing. Right? This isn't too bad. I don't know why I'm getting this wrong. I'm getting all of the ideas right. Correct. Ah, right. This is the issue. Makes sense. Still failing. Let's play the freaking prince and see what's failing. Why undelete? Just unprint it. Just comment it out. Later we will need it anyways. We can do that also. No, I see what's going on here. I'm just not sure why this is failing. They do, that's the issue. No, I get that. I get that. Yes, right. I don't think that's the issue. Oh, no. Ah, it's irritating. L1 minus L2, and we have L2 minus, I think the issue is that we have L2 minus L1 in this. Yes. L1 minus L2 Yeah, I should be passing there. Yay! That's the issue. Batched operations. Okay. And I'm broadcasting. This is the hardest one, I see. Okay. Ugh. It's pretty fun. Okay, I feel my brain's getting fried here. I'm gonna take a 2-minute break and come back as soon as I'm done. Let's see the chat before I start. Nobody's in chat. How many people are seeing this? Please make it 0. Yes, thank God. Macro screen off. Audio.